Again, welcome back, dear student. Today, or the continue of the second day online or e-learning, we are going to talk about one-to-one function and their inverse. So we should know about one-to-one function, and about the inverse of function f of inverse of x. So in general, for showing the function is one-to-one. It's better we have two methods for showing that the function is one-to-one. So our objective for today is, first of all, f of x is one-to-one or not. And the second objective is what? Is finding f of inverse. And the third one is graphing, it's not new for you, f inverse in case it's a requirement or not, or asking about finding the inverse or not. Okay, so in 2.5, page number 79 in your lecture notes, you have the definition of one-to-one and the picture about the one-to-one and horizontal line test. Now I'm going to talk about this definition. The definition said if you have a function and you want to test theoretically to test function is one-to-one or not, which is not easy for you really because you are not a mathematician or you are not in the mathematics department, so you will leave this one. Just I will give you the definition, the detail of the definition. Otherwise I don't ask you about the theoretically. So what do you mean by theoretical? It means that if we input two different values, x1 not equal to x2, then the function, the graph of the first object and the function of the second objects shouldn't be equal. For example, I say f of x is equal to x squared. Now if I put, 2 is not equal to minus 2, but f of, or it's better to start with you should start with the example of the positive part. I mean to be one-to-one. When f of x is one-to-one. Okay, for example, f of x is equal to x cubed. So because 2 and minus 2, they are not equal, then f of 2, we should check this one. We should test this one. It should be, we ask ourselves, is equal or not to f of 2? Or f of 2 shouldn't, f of 2 is equal or not to the f of minus 2. Now, f of 2 is equal to 2 cubed, which is equal to 8. So, and f of minus 2 is equal to minus 2 cubed is equal to minus 8. And 8 is not equal to minus 8. Means that f of 2 not equal to f of minus 2. So f of x is equal to x cubed as one-to-one function. Okay, it's a positive example. When I see positive, I mean to be one-to-one. For the other example 2, I will show you an example that they are not one-to-one. So we see f of x, f of x is equal to, for example, x squared. If 2 is not equal to minus 2, and I will check f of 2 is equal to f of minus 2 or not. If it's equal, means that there is not one-to-one. If it's not equal, so it means that we follow our definition, or our definition satisfied. I mean the definition of one-to-one, the page 79. So the function is one-to-one. Now we will check f of 2 is equal to what? is equal to 2 square, and f of 2 is equal to 2 square is equal to 4, and f of minus 2 is equal to minus 2 square also is equal to 4. So we got that f of 2 is equal to f of minus 2. So because they are, the requirement should be if the two numbers, two objects in the input, in the domain are not equal, the output, the graph, or in the range, they should be equal. They shouldn't be equal. But we put two numbers, they are not equal, but the output, instead of being not equal, I got what? I got equal. So f of x is equal to x squared is not 1 to 1. That's it. So this is the first methods for showing that the example is 1 to 1 or not 1 to 1 or not, by using what? By using theoretical. So how about if I want to show that geometrically it's 1 to 1 or not? What do you mean by geometrically? I mean the definition of horizontal line test. Do you remember we talked about vertical line test for showing the graph is function or not? Now the horizontal line test is for what? Is for showing the graph is 1 to 1 or not. How? The horizontal line test means that if I have a f of x to be like x cube, as I show you in the previous example theoretically, now I'll sketch the graph and I'm using the horizontal line test. The horizontal, you know, this is the horizontal line test. Now I'll sketch the line if the horizontal line test, or if this line intersect with my graph in one point, means that then f of x is 1 to 1, otherwise is not. Another example, f of x is equal to x square. Now, and you know, here's x square, and now I will use the horizontal line test. So graphically, the horizontal line intersect my graph into more than one points, in more than one points. So the intersection points are 2, so is not 1 to 1. It's easier than the other one. So this method is geometrically, and the other one was what? Was theoretically. So you can use the geometrically because you know the standard graph, how to sketch the standard graph. That's good for you. So in the exam, if I say sketch or find the inverse of the function, you cannot find the inverse of the function if and only if, or the necessary condition is what? The function should be 1 to 1. So that's why we study the 1 to 1 and the properties of the 1 to 1, because if the function is not 1 to 1, we cannot find the inverse. So in the exam, maybe someone asks you find the inverse of the function. First of all, you should clarify the function is 1 to 1 or not, geometrically or theoretically, up to you. But I think it's better for you to use the geometrically part. So you should first, even they are not asking you about the 1 to 1 or not, you should show the function is 1 to 1 or not. Then you should find the inverse. Okay. Now, so this is the note for finding the inverse. Okay, we should first show that the function is 1 to 1 or not. If it's 1 to 1, then find f inverse. Otherwise, if it is not 1 to 1, we say f of f inverse does not exist. That's it. Okay, so if I say find the inverse of this function, you say what? You say the inverse is not exist, because the f inverse f of x is equal to x squared is not one-to-one function. Okay, so the other part is what? The other part, finding the inverse. How? Or before I'm talking about the finding the inverse, I have a special case, or a restricting domain, or cutting domain, or restricting domain. What do you mean by this one? For example, if I say y is equal to x squared, where x greater than or equal to 0, this example is one-to-one, or this function, I say f of x, I mean y, is one-to-one or not? That's my new question. So it depends on the cutting domain or restricting domain. I have another idea. So if you want to sketch this one, as you know, we have y is equal to x squared. Okay, but I gave you a condition, like a piecewise function. Do you remember? If you have a condition, how to decide this function is one-to-one or not? So depends on this condition, my graph will change to what? Look, we have greater than or equal to 0. So means that we should neglect or delete or cut or restrict the other part. So that's why I see this is equal and greater to x to 0. So x greater than to 0. So this is the function, this is the graph of what? Of y and y is equal to x squared. But when x is greater than to 0. So this function is one-to-one or not? I don't know. Here's vertical line, horizontal line test. So we have a intersection point just in this point at one place, not two. So that's why I say as one-to-one function. Do not confuse. Don't say in the first time he said, or the function was not one-to-one, but in the second time we say is one-to-one. No, in the second time we restrict the domain. So that's why. Now you know the restricting domain will change sometimes the function. So be careful. The other, also you can say x squared, x greater than or smaller than to 0 is one-to-one function. How? I say this is the part x squared, and this is the smallest part or the negative part of the condition when I say x less than to 0. So I have that part, and I will use the horizontal line test. So I say by horizontal line test, because our intersection point is just one, so is one-to-one. That's it. Now, okay, so this is the one-to-one function, and the cutting or restricting domain. We cut the domain. Okay, now it's time to find what? Finding f inverse, and you have a note for finding the inverse. First, we should show what? We should show the example or the function is what? Is one-to-one. Okay. Now I'm going to continue your lecture. Now I'm going to 81. The 81, we have a property. Now I'm leaving this property. I'll come back for that one, because really I want to show you how to find the inverse of function. So I will skip the page 82 and 82, because in the middle of this page we have an important property. Then after clarifying, or after studying this property and how to find it, then I'll go back to the other part, or I'm going back to 80 page or 80 in your lecture notes. Okay, So how we find the f inverse? First of all, we will change f of x into y, so the steps or the procedures. And the second, okay, so we solve for x, and the third, x is equal to what? And the third, we change x, change f of x into y, and change in the third one, change x to y, x to f of inverse of x, and y to x. I know you are asking me about these words, but it's not difficult for you. I'll show you now. Go to the example number 6. I'm going to solve the example number 6 for you, and I will show you all this. We will apply all these steps on this example. Find example 6, page 82 in your lecture note. Okay, find the inverse of f of x is equal to 3x minus 2. You know, in your lecture you say it's 1-to-1 directly, but for the exam you should first of all don't forget 1-to-1. Do not forget this one. So I say 0 step of the 0 before starting. We have what? F of x is equal to what? That's the x. This is minus 2. That's a 3. So I have something like that, right? 2 minus 2, and this is the graph of 3x minus 2. Now, because I have just a line, by using horizontal line test, we have what? F of x is 1-to-1. Okay, now I'm going to step number 1. You have what? F of x is equal to 3x minus 2. I'll change f of x to y. So I say 3x minus 2. Now you can see it's easy. Change f of x into y. Change f of x into y. Okay, now solve for x. Solve for x means that let be x in this side, and in the left side only x, and the other in the right side. How? I say 3x y is equal to 3x minus 2. Then I'll bring y to here and x to the other side, or I say 3x is equal to y plus 2. Am I right? It's going to the other side. Now, because I want just only x, because I solved just for only x, no more only x, so we should divide both sides of the equation by 3. So I get what? Y plus 2 over 3. Now I solve the function to x, or the equation to x. Number 3, I say change x to f of inverse. So I have what? I will change this one, f of inverse of x now, and change y to x. So I will change this y. I changed x to f of it. Now I will change y to x. So plus 2 over 3. Now our f of inverse is what? Is the function f of inverse of x is what is the function like that. That's all we need and we have. So you saw these 4 steps, especially these 3 is new for you for finding the inverse of the function in your page 82. Now also I'm going to solve. I will leave this one for you as a homework. Please do it, and you know also you have exercise. Now I'm going to solve example 8 for you. Okay, so if I have example number 8, page number 16, I will bring a new page. Here it is. Now, page number 70. Now I'm going to what? To solve the example for you. Example number 8. Example number 8. Page 83 in your lecture note. Okay. Now, what we have? Finding the inverse of the rational fraction or anything. We said rational fraction or anything. So SOC is the name of the function. You know about the rational function. So f of x is equal to what? Is equal to 2x plus 3 and x minus 1. So because the rational function is not easy for you to find the step 0, in the exam I will say, if you know it's 1 to 1, means that the phase will pass, the 0 step will pass. I gave you as a solution for it because I know it's not easy for you to find 2x over 3 plus 3 over x minus 1 is 1 to 1 or not, because you don't know how to sketch the graph of this function, because you know you need to more information about the derivative and something like that, which is not included for you in the college algebra class. So we say we are going to what? We are going to directly to the first step. The first step say what? Say change f of x into y. So I have what? F of x is equal to, or directly I will write down for you. I know you are clever. So I will say y is equal to 2x plus 3x minus 1. Okay, now the second step. The second step will say what? Solve for x. Now I say y x minus 1 is equal to 2x plus 3. You know why? We multiply the both side by x minus 1. That's why. So I will get what? Yx or xy minus y is equal to 2x plus 3, and I'll bring the xy minus 2x, and I'll take the y to the other side. I'll get something like that. And because I want to solve for only x, I mean single x, you know, so I get what? Y minus 2 is equal to y plus 3, and x is equal to, you know, y plus 3, y minus 2, because we divided by both sides by y minus 2, because I want to use only x, and I get the denominator here. Now number 3, step number 3, I say change x to f inverse of x, and wait, so I get what? F inverse of x is equal and what? And y to x. So I get what? I get plus 3 minus 2. So x. I think it's easy. Now by practicing, by solving more example, you can see it's very easy, and you don't know to count the to do everything. In some example, if they are easy, for example, like example 16, example 1, sometimes I will add the question for you. I say find the f inverse and sketch it, and sketch the graph. When I say sketch the graph, I mean the inverse graph. You know how to sketch this one. You have x, you have plus 2, plus 3 over 2. So I have what? F inverse of x is equal to x over 3 plus 2 over 3. So you know how to sketch this one in the 2.2. I told you have x over 3, okay, and plus means that going to up, because outside the graph is not like that. So y, or you can see f inverse of x is equal to x over 3 plus 2 over 3. Or maybe in some example, like example like this example 9, say what? Say graphing the inverse of the function. when x minus, the function is x minus 2. So find the inverse and find the equation of the inverse, or graph the inverse of the function. So how you'll do it? You'll do it easily. You will apply the three steps. So we will solve it for x. We change the f of x into the y. So it's the first part, and we will change it to the. We will solve it for x. Now here's the second, and y should be greater than, because y is equal to the square root. And the third one, we will change the x into the f inverse and y into x, and you'll get the graph of the function. So we will, because I have what? I have x minus 2. This is my original function. X minus 2, you have 1, 2. So because we got x squared plus 2 means that we have x square, and plus 2 means that going to up on shifting for up, shifting to up. So I get 1, 2, and I have something like that. But because this x square, and from the beginning y was equal to what? Y is equal to x minus 2, and the value of x should be greater than or equal to 2. So that 2, 0, x minus 2, so should be greater than or equal to x equal to 2. So I got some process, and I get what? I get y is equal to x squared plus 2, and the square is not inverse, has not inverse, because as I told you, vertical, we use horizontal lines, so that's why we neglect this part, and I get the original part here, or the original part of the inverse here, like that. So this is my inverse function. I hope you get the idea still here, and we will I will continue with the smallest things between 81, page 81, and half of page 82. Yes, here, if you want to check the inverse is right or not, we should composite them to each other. How, or what I mean by this one? For example, we found the example. Sorry, it is in 18. I found this example. I see f of x in the example 6, page 82, 3x minus 2. And after together, I show you that the inverse was equal to what? Equal to x plus 2 over 3. To ensure that the inverse is correct or not, I'll show you. You should use this property, which we say the identity property. We should composition the function with its inverse, and we should get what? Just x. How? I'll show you here. I'll say f inverse of x. Do you remember the composition? Yes. You say we will select the f, and we will change the clause. We will use the closed bracket, and we say f inverse of x. Do you remember that? Okay, so we will put the inverse function, which is equal x2 over 3. Am I right? Because here's the inverse. Now I will use the f of this one. If I put the f, I will get 3 multiply x minus 2. If I put lambda, for example, I'll say 3 lambda minus 2. So I'll first multiply by 3, then after all of them, I'll say minus 2. So I see 3 multiply this lambda minus 2. This is the input of output of the function f. So we can canceling these 3 with the other 3, and I'll get plus 2 minus 2 and you know they are each other. So because f circle f inverse of x are equal to x, so it's right. You got that? Good result. So also try to do it, for example, page 17. Where's page? Sorry, page. Yes. Also, we will apply this for the page 70. Example 8 in your page 83 in your lecture notes. So I have what? F was equal to 2x. F of x is equal to 2x plus 3 over x minus 1, and f of inverse we found it together was equal to x plus 3 x minus 2. Now I will apply this property the page 82, 81 to 82. You can see also there's an example. You can apply this rule and I will get what? This time I'll use f inverse or f circle f inverse of x. S is equal to f of f inverse of x and is equal to f of, where's f of inverse? Okay, so how about f? If I put lambda, I will get 2. We have a fraction here. I will multiply 2 plus 3 minus 1. Lambda. So the same thing is for here, like a lambda. So I say I have a fraction 2 lambda plus 3 lambda minus 1. What's lambda? Lambda is equal to x plus 3 x minus 2. Here's also x plus 3 x minus 2. And you can see we find the common denominator, and you can see after a little bit step you get x. Please try to do it if you want, if you can. If you can't, I will help you in the page 19. I will do this quickly without speaking, just I'll do it for you. Now I will find the common denominator. Chapter 1, we talk about this one more. So yeah, we have a lot of things about this. Also for the denominator, we need a common denominator again. Now two x plus 3x is equal to 5x, and this will remove, that one also remove, something error here I think. Yes, sorry, we have a plus here, sorry. So I get 5, we have a plus here, not minus. So I got x in the page 19. That's all. Hope you understand all the lecture, and if you have a question, as I told you, you can ask me online on the next section. Thank you very much for watching the video.